Hi, I'm Jeremy James Rojas. I'm gonna teach about the physics of sound. But first, would you like to look at my t-shirt for a moment? Isn't it corny? Now, let's get on with the lesson. The physics of sound. Why do we hear what we want to hear? Turn on your speakers. But I don't have a speaker. So, let's skip that. Sound is made when something vibrates. The vibration disturbs the air around it. This makes the changes in air pressure. These changes in air pressure move through the air as sound waves. The sound waves cause pressure changes against our eardrum, sending nerve impulses to our brain. This is similar to throwing rock in a pond. Air molecules ripple through the air in sound waves like water waves rippling across a pond. There are three components of sound, and it is pitch, loudness, or timbre. Pitch. The vibration patterns of some sounds are repetitive. Vibration patterns are also called waveforms. Each repetition of a waveform is called a cycle. We can hear frequencies between 20 Hz or cycles per second to 20 kilohertz high pitches. When the frequency of a sound doubles, we say that the pitch goes up an octave. We can hear the range of pitches about 10 octaves. Many animals can make sounds and hear frequencies that are beyond what we can hear. Loudness. To create vibrations, energy is used. The greater amount of energy used, the louder the sound. The strength of the changes in air pressure made by the vibrating object determines loudness. As the sound spreads out from its source, the concentration of power becomes less. As the distance from the source increases, amount of power is spread over a greater area. The amount of power per square meter is called the intensity of the sound. Humans do not perceive sound intensity linearly. For us to perceive a sound as twice as loud, its intensity must be 10 times greater. The perceived intensity level of sound is measured in a logarithmic scale using a unit called decibel. The scale begins on the softest sound that a person can hear. This is called the threshold of hearing. The scale ends at the volume that causes pain, which is 120 decibels, and is therefore called a threshold of pain. From the perspective of logarithmic scale, the threshold of pain is 1 billion times as great as the threshold of hearing. Here, the picture above is a wave file of someone singing. The chart on the left is a representation of different sounds around us and their volume in decibels. Timbre, or tone color, is the specific property of sound that enables us to determine the difference between a piano and a harp. An extremely broad variety of tone colors exist because most sounds that we perceive as pitch actually contain many frequencies. The predominant pitch is called the fundamental frequency. Although we would perceive a string vibrating as a whole, it actually vibrates in a pattern that at first appear to be erratic, producing many different overtone pitches. What results are particular tone colors or timbres of instruments and voices. This one. The other frequencies which occur in a mathematical series are called the harmonic or overtone series. When C1 is the fundamental following pitches represents its first 15 successive overtones. This one. And now, We are finished with the lesson. Goodbye.